storage, storage virtualization, and storage-based virtualization. It is really funny because I do hold currently 4 storage certifications, and storage-based virtualization is it's a growing topic. And one of the big areas that I keep running into is, are storage area networks going away? Is storage devices, dedicated storage devices going away? And how can we virtualize storage appliances? Because that's been another big one, is SANs are expensive, so how can we virtualize that storage space? Or can we? And those are some of the topics that we're going to discuss this week. So first, history of network storage. The technology for network storage has changed throughout the years. We've gone from just traditional IDE/SCSI/fiber channel storage networks, so storage devices, to our current situation of everything being converged to a data network. So we have fiber channel over Ethernet. We have iSCSI, which is just SCSI sent via an IP packet. Don't get me wrong, fiber channel is still out there and still kicking. It's just we're finding ways to increase the flexibility of our data network, and that's becoming high-end backbone storage. That's been a really big thing lately, is we already have this infrastructure, we need a way to put storage on it. So the first type of storage used in the network would access data directly through a workstation or server directly. So directly accessible storage, DAS. Again, direct access storage. And that's different from a SAN, a storage area network. That could be a networked device that is attached to the network directly, and then you connect to it. It does differ slightly from a NAS, network access server, because again, that's also direct. It's directly accessible on the network without having a front-end server trying to kind of modulate resources to it. Not modulate, but control resources to it. So that is one of the considerations. But yeah, the first one was direct access storage, but that meant only one device had access to that storage. Hard drive, floppy drive, tape drive, anything that directly attached to the workstation was considered storage. In reality, that wasn't good enough anymore, because we're having more and more storage, more and more data that's populating that storage, and we had to have ways to share it. And things that are on a local copy of one device may not be accessible to other devices. That's one issue. Another issue is version. Oh my gosh, version is a big thing right now. Part of the phone call I was on before this PowerPoint was a version mismatch for a research plan. And it was my advisor had one version, and I was working on a version 4 versions ahead of him. So part of that was, hey, we need to fix this area. And I'm like, what are you talking about? On my version, or the current version that I'm working with, that doesn't exist anymore. So version history is a really big issue. But I mean, we didn't have that issue with this directly attached storage. It was only when we moved away from that, when we put things on the network, that version became an issue. When an individual wanted to access data over the network, the drive was mapped and access made available, meaning we mapped a physical resource on one device to another device to mimic or to simulate as if it was local. The drives appear to the client as shares. These shares are represented as a path, a UNC, a universal naming convention, or a unified name, and that is / the server name or IP address / the share. The slash here is very important. They are not forward slashes. They have to be double backslash, because within our file format, our Windows environment realizes, oh, that is a network resource, // First thing it's looking for is standard, is the name or IP address of that resource. If you just did / name or IP address, then it would list all resources that device is sharing. That way, if you don't know the share name, wasn't that big of a deal. The task of performance monitoring, providing availability, security, became more complex when it was all direct attached storage. And that's because someone could check it out, manipulate it, change it, put it back, and some data could be overwritten or damaged, and no one would know until they needed that portion of that data. The drawback to this arrangement was the server normally had other functions to perform, meaning that it wasn't fully dedicated to just data storage. If we tried centralizing everything in one location, it does make backup and access to that data easier, more accessible. But that server normally, or that device that's doing it, normally is not tied to just that one task. So the issue with that is, by it performing just that one task, it could be underutilizing that server and all of its resources. This type of access worked for small businesses, while in other areas, things like larger or medium businesses where data-intensive operations, as well as the amount of people using it, grew. In a small business, a small server with data access might be okay, but when you have 100 or 200 users connecting to a small server trying to access data, all of that quickly adds up and can become a problem. However, as companies grew, the drives and servers not only needed to be maintained, but needed to have the network maintained, as well as other resources needed to be available. For example, for the data network, what was going to be maintained? The data network, the data traffic, the storage traffic going through it, and how could you provide any form of service guarantees if it wasn't maintained correctly? So that's all our big questions that we're here to answer. In time, data input, output, performance, availability, and performance, because of the size of it growing, became very difficult. Many organizations do not realize how difficult it is to manage data. So with that, the difficulty is to manage that data as it grew. Organizations like EMC and EqualLogic started realizing the importance of centralization. And it's not so much centralization for the sake of centralization. Things like backup and a management of that data is very important, because in a way, our data helps drive most of our business decisions. So when we have no way to manage that data, it makes making certain business decisions extremely hard. So that helped develop our NAS, our network attached storage. And this was the response to the centralization. A NAS normally has software on the unit itself or on the device so that it can be directly accessed on the network. And this is a major area in network storage. The idea behind NAS was a specialized appliance that was completely dedicated to managing network data. Essentially, you can think of putting hard drives on your data network so that people that are access to that data network have access to that storage. The NAS devices were designed with hardware specific to that purpose. Better quality hard drives, a SAN controller or a NAS controller that would allow IP communication, dedicated software to run that unit, a backplane so that the hard drives, when they were put into a unit, could access memory as well as that data connection. Network NASs are outfitted with a basic operating system that is specifically there for data management. Right now, Server 2012 does have a storage portion. That way, if you wanted to have a customized storage device using Server 2012, you could do that. Because organizations are starting to realize the importance of that data management. Data is the lifeline of decisions. Other items like firmware and applications were optimized for that data, as well as the intensity of that data, so that they would be able to handle all of these storage operations. Again, those are tasks like monitoring, management, backups, restoration, snapshots of copies, backups of individual copies, some form of RAID or availability or redundancy. All of those were major tasks for our NASs. That way, if a file got corrupted, you could, through the hardware, try to recover it. Or if you had backups, through software means. Another thing here was increased security, so that some of these storage devices could be using NTFS or other storage permissions so that data could be secured. NAS has provided, again, that centralized management portion. Winston, go. So that those that were administering that storage could do it a lot easier. People go, well, storage isn't that hard or that complicated to manage, but it can be. An example today, I was at a data center and we had maybe 50 storage units to manage. Each storage unit held about 15 terabytes of data, and instead of having one large NAS or two large NASs, they had several small NASs. And just the management of that, because as data is coming in, where is it stored? Where's the performance? Are people able to access their files relatively quickly? All of those were major issues. Again, because of the storage capacity has been increasing, it was way too heavy for just a NAS. So this was the beginning of the increase of users and critical application and that constant data availability and data access and the faster input-output requirements for the larger businesses. And it became evident that a better solution was needed. And that solution became a SAN, which basically was a storage area network. And this could be several different types of units. So a storage area network could be what you'd describe the network as. You have a dedicated network that is just used for storage. That's a storage area network. However, you could also have a dedicated device, a storage area network, that is a centralized unit similar to a SAN that normally has, again, its own dedicated network. A SAN is a standalone network solution to provide storage on the network. And that's going to be fast storage and available storage on the network. Typically, SANs promised many benefits. Extremely great performance, availability, it's scalable, capacity, could be fault tolerant, redundant failovers, as well as quick replication of data. And early SANs met most of these. While we're still growing, a combination of EMC, EqualLogic, and Dell units we're a Dell partner and we're an EMC partner as well. The scalability for these devices is high. Capacity, same thing. As we need additional storage, it's simple. You plug in devices, you run a wizard, and you have additional storage. Though managing all of the devices, it's kind of complicated, especially as we start going into fault tolerance. Because then we have to have backups of devices. That way, if a device fails completely, we have another device that auto kicks in. But again, all of this is tied back to our data, and with an organization that deal with this mass amounts of data, that is totally appropriate. So let's get into some storage virtualization. Storage virtualization is the act of abstracting, hiding, or isolating the internal functions of a storage or subsystem or services from applications. Compute servers or general network resources for the purpose of enabling application independent management of storage data. So what the heck does that mean? Basically what that means is the underlying storage is meaningless to our applications and our devices. It's there, you can access it. How we access it, it does not care about. For example, if we had a server and we wanted to add an additional LUN, logical unit number, for a storage array, so that that server could access that storage array, a group of hard drives that is normally called a LUN, that's a logical unit number, so that you could access that dedicated that dedicated portion of storage. So even if you have a 15 terabyte storage, you might carve it up into 15 1 terabyte pies. Each section is given a LUN. That way you can directly access that specific LUN. So with that said, you can have servers that have direct access to a LUN, and the server itself does not know that that storage is not local. It will treat that network storage as local storage, and it doesn't know. When you click on a save document, or the save button on a document, it treats everything as local hard disks or local storage, even when it really isn't. So the front-end system, the system that the users interact with, it may seem very simple and straightforward. However, the back-end may not be. Storage Network Industry Association, SNIA, defines 5 very specific categories for virtualization that occur in storage virtualization: block, disk, tape, file record, file system virtualization. That way we can virtualize the file blocks, the file disks, the tapes, the file records, or the file systems. So, what is disk virtualization? Is what happens or occurs when the physical data laid out on the disk is mapped to a logical data layout. Meaning it's not mapped to a single physical disk. It's mapped out to a logical disk. For example, a RAID array. The system only sees one logical mapped out layout. However, physically there are 2 disks or 3 disks, all depending on how many RAID or how many drives are in your RAID array. The application dealing with that disk at the logical data level, it doesn't understand that it's there. An advantage of this is that damaged sectors are masked from the host and the data is remapped to a good sector. Meaning that if a drive has failing parts or failing sectors on the drive, things just won't use it. Storage will not use it. So what does all this mean? If you've ever done a simple RAID setup on a PC, you should know that first and foremost, that the array itself is given a LUN. it is given a logical data unit as well. The LUN helps map things to it, resources to it and from it, while the logical data unit lets it know that it's a logical unit. And then it will try to mimic as if it was a physical unit. But with that said, basically, it assuming that we have a RAID 0 array with two 500 gigabyte hard drives, the RAID system will match the two, pair the two, and then give it probably a tenth of the space for its room to grow, for its database tables. And that's pretty straightforward. However, the data is logically distributed between both. That way it's not physically just stuck on one drive. Logically, it's on two or more drives. It's the operating systems that keep track of these bad sectors and then try to fix them later. However, the host only deals with the free space cleaning blocks, meaning that hard disks, when they start dying, try to fail. Sometimes those hard disk failures could be repaired. It kind of depends on the situation and what's going on. So how does this help on our storage? So this method basically allows or frees up the system to focus on just cleaning data blocks. It doesn't care about bad sectors. That's the device's job. That way the device can map around those bad sectors or try to repair them at a later date. But this way the servers or the end devices that users are connecting to or from can concentrate on the work that they're supposed to be doing. So how do we virtualize tape storage virtualization? When a tape is written to or read to a disk, storage is used as cache. Data are temporarily maintained by this cache during the process of writing and reading the data. If there is any fluctuation or bottleneck in the network, the cache acts as a buffer. Basically, it says that we're going to allow X amount of people to board a boat, and if we don't follow through with that, then it just bad things happen. This protects the tape from stop-and-go motion of accessing the data. The mechanics involved in this motion would cause wear and tear on the tape drives, as well as reduce its speed. But basically, you give up some of that speed so that in a longer term you can do better. This depends on situation. Keeping the tape in streamlined mode increases utilization and reduces wear. It can also then lead to an increase in speed. In addition, if used in a storage area network, environmental tape can be placed in pools of tape libraries and are available to all servers for use. Whenever a server needs to access that data on the tape, the SAN assigns the drive letter to that storage server or that server and then returns the drive to the pool when the server or resource is done being accessed. All of this controlled seamlessly by the controller on the SAN. It's part of what a SAN does. Other background work can be done by the SAN, such as tape drive backup. Storage users will not be aware that the mechanics are being used. That's a big thing. People do not know that the underlying technology that they're using is what it is. So, again, a big part of that SAN is its dedicated hardware so that all the tasks can be ran on the SAN itself, not on the servers, or not where end users can see it. If you have ever used cloud services like Google Docs, or Dropbox, or OneDrive, you're accessing a SAN. You just don't normally realize it. To us, we just see storage. But in reality, this is probably a very vast storage network where our files are located on hundreds of servers That way, if one storage unit goes down, our data is still there. But again, we as end users don't care about the back end. We want to know that our data is going to be there. So there had to be some type of mechanism put in place or employed so that end users would not be aware of what was going on. End users want the availability, want the access, and that's it. They don't care about how it works or how it functions. It wants to know, or they want to know, that it's going to work and that their data is always going to be available. So what's file system virtualization? Files are shared on the network and made available to many hosts. It's a way to share files on the network. Even when running different operating systems, the files are accessible in the same manner. Meaning, if you have a Windows machine and you want to access it from a Linux machine, it doesn't matter. Files should be the same across the board. Well, now we all know that they use different file systems, but there is a common file system out there for shared storage. CIFS is one of the big ones. Common Internet File Systems. That way, most operating systems can access it. NFS shares, Network File Shares, NFS, is another big one. But that way, regardless of the operating system, you know that you can access that data. File record virtualization. Normally in a hierarchy storage, we categorize based off of usage. These files are used less frequently or placed in storage media that's less expensive. Basically, if a file that is not used often is needing to be stored on a SAN, it goes on the slower drives. Or maybe a backup or an archive section, versus data that does need to be accessed every day quite regularly can be placed on faster drives, because faster drives are more expensive. A great example that's happening right now is users with SSDs are putting SSDs as primary drives, but because of their small capacity, they're using a secondary drive for their profile data. That way, Windows and installed program installed to the SSD, but things like the program or the user profile and others, maybe not as frequently used programs, are put on a slower mechanical drive. That way, things that need that speed have access to that speed, versus those that are okay with that slower speed get that slower speed. This allows for higher frequency data items that are accessed. They can be accessed quite faster, because again, they're placed with faster storage. And again, none of this is ever brought to the attention of the user. When you pay for certain storage services, especially online, it could be that they're on older SATA drives. It could be that they're on brand new SSDs. Just kind of depends on the underlying storage of that organization. Storage is not cheap at all. So that's something that should be kept in mind. What is block virtualization? Block virtualization means transforming physical disk storage into virtual disk storage. The virtual disk will be managed at a block level rather than at a file level. Implementation is seamless because it's set up without involving the applications, meaning each block of hard drive space is now based off of individual blocks. No longer do you have to access the entire disk at a file system level, meaning you can actually take one hard drive and partition it into different areas. That way it can take part in a RAID 5 array, a RAID 6 array, a RAID 1 array, and not have any problems being attached to multiple different RAID systems. Because this is done at the block level, not the file system level. This type of virtualization adds the flexibility to combine physical disks to be seen as on large disks. RAID is a type of block level virtualization, or it can be broken into several smaller virtual volumes depending. These volumes, also commonly referred to as partitions, can be associated with a specific server. That way one server or one file, one folder, could be shared with one server, another folder could be shared with a different one, and a different one, and a different one. That way we can centralize our storage, but still pass those shares off to one another. These increments are seen at the block level. Logical volumes allow the user to be unburdened by the issues of capacity, performance, or reliability. On a SAN, as long as there's physical space still available, you can always take the space and allot it to additional people or departments or groups based off of needs. The disks are highly available and reliable. Normally they're using enterprise class drives, and quality does show. The disks can also be striped across the physical drives for better performance. Again, this is a form of RAID. You can actually portion the data on multiple drives to help speed up performance. However, issues with that involve having the appropriate, system, having the appropriate setup is also a big one. That's one that I encounter quite often. Organizations, they have so much data. They have data flowing out every orifice, yet they don't want to analyze it. They don't want to review it or look at it because it disgusts them so much that they maintenance. Another thing for block level virtualization is maintenance. You can add, remove disks, fairly simple. You can do mirroring copies, so you can get duplicate disks. You could also do upgrading disks that are live. That means there's data on them. You can pull them out and put them on as need be. I ask, does this matter? And that's a big thing, is this does matter. Storage is important. Understanding block level or file system level, understanding that you can share data so that everyone can more easily access it, or make it more accessible to everyone. This is becoming a huge area. For an institution to collect data and not analyze it, to actually make meaning out of it, that's kind of pointless. But I mean, so many organizations are at the point where they're combining all of their mass amounts of collected data and turning it into very useful information. Big data is all over the place, and it's growing. So yeah, understanding how systems share resources, how systems share files and generate data, that is a huge thing. So levels of conducting virtualization. Again, it can be done on 3 different levels. The normal transformation are host, network, and storage level. And each of these levels can be manipulating the data and then transform it into some type of information or something to be served to the next level. A host can access data locally or on the network. The host could also access data that's on the network and as well as the storage device. That storage device would access the storage level to pull that data, put it back on the network, give it back to the host. So those are really big items here. Host-based transformation. Data can be transformed mainly at the host level by volume management or by disk management or partition management. Volumes can be enlarged, grow, or shrunk reduced without really affecting any application. Things like software RAID can also be implemented, and that is via software allowing multiple disks to act or to simulate one disk. Well, normally you want hardware RAID. Software RAID still does occur, sadly. This allows for faster access to data, because normally we're talking RAID 0, RAID 1, RAID 5. 0 is striping, so half the data is on one disk, half the data is on another disk. That allows for fast access of that data. If we're talking RAID 1, we're talking complete 100% backup of the data. So it's a little slower than RAID 0, but again, it's duplicate copies. So if one disk fails, it doesn't matter. A second 100% identical copy is there to take over and get you going. Versus RAID 5, which is just bulk storage, with some form of parity so that the data could be rebuilt. With that said, these are only three of common types of RAID. There's RAID 6, there's RAID 10, 100, 50, so forth, so forth, so forth. RAID can come in many flavors. Sometimes RAID can join together to form multiple types. For example, RAID 1 and 0 can form together to form RAID 10. That way you have two individual disks that are looking to group together in RAID 1. Or I take that back, in RAID 0, because they want fast access. Then, each of those disks is also associated with a RAID 1 array. So now instead of having two disks, you have four. But again, each of the side of the RAID 0 has a backup disk, so that if that disk fails, there's a backup. As data grows, so does the need to add and manage that data via volumes or partitions. If more hosts are needing to access that data, then we need to work on some type of network-based storage solution to accommodate those servers accessing all that data. Now let's move on to storage-based virtualization. Storage-based virtualization can be achieved. One of the big achievements here using one or a combination of the following types of methods. RAID array. Again, RAID 1, 0, and 5. Could also maybe use snapshots. A snapshot is a backup of the data, normally done on storage units at a specific moment in time. Kind of like Windows backups, that's just a moment in time. So anything that's there could be reverted. So an important one after we talk about RAID and snapshots are our logical unit numbers, our LUNs. Again, masking is accompanied by moving and transferring data at the block level instead of at the file system level. But we have to have a way to uniquely identify those units. So we give it a LUN number. A LUN is a very long number which is very unique. I don't have an example of a LUN number right now, sadly, but they are there. And anything that's accessing storage is truly accessing the LUN number of that storage. We don't access the storage directly, we access the LUN number that allows us to access it through that number. Basically, is how do we address that volume or that storage? We do that through LUNs. How do you address a home? We do that through physical mailing address. So there are ways to do this. So the flexibility of LUN masking allows for faster system performance during data transfers, especially when we're working with databases and large images. I/O-intensive applications that can easily handle the storage area network. Basically what we're talking about here is underlining hardware is oblivious to the above software. Just like the above software is oblivious to the underlying hardware. It sees there's a hard drive there, so there is storage, that's E drive. But in all reality, that really is the storage unit. And organizations just quite don't realize that or pick it up yet. The addressing data using blocks allow for the ability to create logical units. A LUN can be thought of as a virtual disk drive, again, a virtual container for storage. A logical unit can appear as one volume, even though it's made up of several physical disks, so that the actual device, the computer, recognizes it as one, even though in reality it could be 20 or 30 or more, depending. It can be configured with one volume representing one entire disk array. Equal logic does that, I don't like it. That way, if you configure the entire unit as RAID 5, the entire unit is RAID 5. I don't really care for that, because I'm used to the Dell MD series, which allows you to group disks based off of your needs. So that one storage array could be a RAID 5, or could be a combination of RAID 5, RAID 6, RAID 7, and so forth. So that is one consideration. Again, number masking involves logically slicing up the disk or combining the disks so that there can be space for all of them, or there could be additional LUNs that are created. And this can be dedicated to a single server or multiple server. And again, the SANS controller manages these LUNs so that the data is not corrupted. Basically, between you and the device, the SAN, if it's acting as a middleman, doesn't allow data to be corrupted easily. Sometimes things happen, but not very frequently. Keep in mind the benefits realized by these storage-based methods are confined to a specific array of disks, and they are not realized across multiple array types. We could also do network-based virtualization, which that could be a LUN over a WAN, or maybe even a virtual WAN or LAN connection for storage. Those are all major considerations. So, we can also then slice up a LUN into smaller LUNs. We can ensure security to a single host by assigning just that LUN that accesses that particular volume only to a specific server and block access to all others to that LUN. There's different methodologies. This kind of depends on what you're looking for. And that is it for this week. I wanted to thank you guys and hope you guys have a great evening. Okay, so I wanted to discuss some follow-up items. One of the first things is our APA formatting and citation. That goes for both our IPs and our discussions. Remember that we have to do all of our work according to the APA manual. So if you're not sure how to do that, go online. You can type in APA formatting. If you don't want to look it up online, you can go to any of the tutorial services. We have a writing, we have a library service. They can give you additional resources on how to do APA formatting. That's important. That's not going away. In discussions, same thing. We have to be doing our citations in our discussions, because one of the big things is, for our citations, we're building off of other people's works. So it's a way for us to verify what we're claiming is supported by the literature. So when I say something at the sky is blue, you can take my word for it, or if I provide a citation, you can take an expert's word for it, and then I built off of that. So it just kind of increases your credibility. We should be at least citing in every post, or as much as possible, because again, we're trying to link what we've done back to the literature. Same thing in our IPs. Every paragraph should be tied to a source. Every paragraph is an idea, and every idea we need to have support within the literature. And I know at this level it's not that big of an issue, but you want to get in the habit of doing that, so when you start doing higher level work, it's second nature. Also, length. We don't need posts that are great job. I mean, don't get me wrong, it does add to it, but when I start grading for posts, I'm not doing full credit for those that have 3 posts and 2 of them are great jobs. I don't count the great jobs as a post. For our discussion board, I'm looking for 3 solid responses with citations. For our papers, I'm looking for 3 pages of content with citations. So what I mean by content is that's 3 papers on topic. That's not a cover page, that's not your reference page, that's 3 content pages. 2 if you're really good, but I'm really looking for 3 if you're doing diagrams. Diagrams totally are okay, as long as you're doing them within APA formatting. Lastly, grading. Again, I grade heavily off of attempt, like if you're putting an effort into it. Like if you did 2 pages and you did a few citations, and I could see that you were making an effort, I'll meet you. But if you post once, or you did a page and a half with 1 citation, that really isn't you making an effort. If you get stuck, don't get me wrong, some people a page is a lot. If you get stuck, you have plenty of resources to bolster up your paper. You can contact me, I'll help you. If you don't want to contact me, we have a writing center, we have a tutorial center, we have plenty of help for you to get. If you need tutoring, there's a lot of tutoring out there. And again, provided from the school. All you have to do is say something. For our tutorial lab, we have tutorial services for SQL, we have tutorial services for database, we have tutorial services for math, English, writing, research, library services. I mean, we have a great amount of tutorial services. And if we don't offer tutoring in a specific area, you can ask for it specifically, and they will find tutors for you. So you could not get tutoring because you can. If you ask for help, the school will get it. If you cannot get it from the school, there's other help. I will sit down with you. I will do as much as I can with you if you need one-on-one. If you need tutoring and you don't get tutoring, that's not a failure on my part. That's not a failure on the school's part. That's only a failure on your part, because there's plenty of opportunities there. You have my number, you have my email, you have 2 emails from me, you have my cell phone number, you have plenty of ways to get a hold of me if you need help. And again, if you don't capitalize on help and you need help, that's on you. Because there's plenty of help out there. All you have to do is say something. Thank you.